Finally, let's combine all these conversions to actually return to a problem we had in AC analysis. One of the challenges we had is that this right here was in a polar format, and this right here was in a Cartesian format, and we were worried about combining the two elements. But now we have the ability to convert between the two coordinate systems, and so the first thing you want to think about is what coordinate system do I want to move into? And because all of our operations here are multiplication and division, we're going to move all of our quantities into a polar coordinate system. And so if we take a look at J4 as our first one, often in my notes you will see a little sketch over here to the side that helps me lay out what these objects actually are and help do the conversion. So J4 has no real component and only has an imaginary component. So J4 actually is 4 e to the j 90 degrees. So this has length 4, but this is a 90-degree angle to get you up there. This was 5 e to the j 53.1 degrees. So as we rewrite this problem here, I will replace the Cartesian values with these new polar values. So J4 becomes 4 e to the j 90, and 3 plus J4 becomes 5 e to the j 53.1 degrees. Combining everything together, we get 15 e to the j 120 degrees. We combine sort of our like terms here. This becomes 4/5 e to the j, and then it'll be 90 degrees minus 53.1 degree. And our final result, so 4/5 of 15 is 12. And then combining all of our exponents together, our result is negative 83.1 degrees. And this was the quantity that I gave you in the problem, and I said just trust me. But where this comes from is 15 times 4/5 gives you 12, and then negative 120 plus 90 minus 53 gives you negative 83.1 degrees. So if you were to do all these things by hand, you would have to do all of the conversions yourselves and do the work. But we will see how to do all of these things inside of a calculator or inside of MATLAB to reduce the number of errors and possible ways that you can go wrong in doing all the operations.